Right, today is the last discussion on the shapes of molecules and ions. In this chapter, we'll be discussing about the various structures of molecules, how we determine the structure of molecules and the shapes of molecules. Rather than memorizing the shapes and the structures, the most important thing is you derive the shapes and structures, because many tend to memorize the shapes, memorize the structures. That is not good, because if you come across unknown molecule, a molecule which you came across for the first time, you will not know its structure or the shape. If you just start memorizing various shapes and structures, so the best thing is apply certain rules and derive the shape. So let's see how the shape is derived and the structure is derived. So I'm going to first concentrate the first half of the class on deriving the structure of the molecule, and then the second half we'll discuss about the shapes of molecules. Right? If you can derive the structure, the shape is very easy. Now the structure is represented by the Lewis theory. We draw the Lewis structures. When I say Lewis structure, what I mean by Lewis structure is a structure which a single bond is represented by a single line, double bond is represented by a double line, and a triple bond is represented by a triple line. Now these are the basic few of the basic simple Lewis structures of simple molecules, right? Now when I say structure and the shape, remember what I mean by structure and shape of molecules is that it is covalent molecule. It's not ionic compounds, because ionic compounds, they exist as giant crystal lattices, where one cation has many anions around it, and those anions have many cations around it, right? That is the structure of ionic compounds. When I say the structure of molecules here, what I mean by that is covalent molecules, not ionic compounds, right? So we know how to draw the structure of a simple covalent molecule such as hydrochloric or carbon dioxide or nitrogen, even water. Right? By looking at the dot and cross diagram, we can easily draw the Lewis structure of a simple covalent molecule, right? So how about giant covalent structures like, for example, sulfur trioxide or even sulfite ion? So how can you derive the structure of these complex molecules or ions? For that situation, what we do is we don't memorize structures. It's not a simple structure, because we don't know how many bonds are there with sulfur and oxygen, how many bonds, right? So many students tend to memorize shapes and structures, because I'm going to explain to you a different approach. In fact, that approach is helpful for you to derive any shape, any structure of any molecule, any complex molecule. Because, for example, I don't memorize structures or shapes. Now, if you ask me straightforward, what's the structure of phosphate? Honestly, I don't know. I don't know the structures or shapes of most of the molecules, because that is not how our professors taught us to study chemistry, because we don't memorize anything. Because I can derive the structure and the shape of any molecule without any mistake. Even a new molecule which is invented, I will know the structure and the shape of it, right? Because we know the principles of deriving the shapes and the structures. So the most important thing in chemistry is that rather than memorizing, because many teachers don't do this section, because they just give you a A4 sheet, and you have for 3 columns, you have in the first column the structure, second column the shape, and the third column the bond angle. So give about 2-3 sheets, about 40 to 50 structures, and tell you, okay, you should know these structures. This is absurd, because it will be very hard upon you to memorize all these 20-30 structures, right? But if you know 6 rules, there are 6 rules. If you know these 6 rules, you can easily derive the structure or the shape of any molecule, any molecule. But when you practice for the first time, it will take some effort, right? Because it's just like driving a vehicle. On the first day when you start to drive, it's a lot of effort, because you have to know, especially if you're driving a manual vehicle, it's a bit hard, right? But after 1 week, you will be just driving without any effort. You will, because you know the technique. So likewise, this is the first time when you do, you have to follow the 6 rules, and then the next, second, third, fourth time when you keep practicing, you will do it within few seconds. Now I can derive the structure and the shape of this molecule within maybe 10-15 seconds. But if you ask me straightforward what's the structure of phosphate, I don't know. But if I give me 10 seconds, I can deal with the structure without any mistake. So this is what I'm expecting from you all, right? Okay, so now the structure, I just start with the sulfite. When you draw the structure, the first step is that you have to identify the central atom and the terminal atom. Now, central atom is the atom which is found in the middle where the rest of the atoms are bonded to. So how do we identify the central metal ion or atom in a complex ion or molecule? That's very simple. The least electronegative element is the central atom. What is central atom? The atom which stands in the middle, which other atoms are bonded to, right? So how do you identify that? The least electronegative atom. You know sulfur and oxygen. Sulfur is below oxygen in the group 6. Right? So electronegativity, we know down the group decreases. So sulfur is less electronegative compared to oxygen. It's less electronegative, right? So sulfur becomes a central atom. So remember to identify the central atom and the terminal atom first. So the least electronegative atom will be the central atom. And there is one exception to this rule, that is hydrogen. Hydrogen will always occupy the terminal position. Hydrogen will not occupy the central position because the reason, hydrogen cannot form two bonds. It can only form a single bond. There's only one electron. It can only form a single bond. It cannot form multiple bonds. So hydrogen will always occupy the terminal position, right? Even though if it's less electronegative. So this rule, the hydrogen is not included in this rule. It's exceptional, right? Am I clear? So hydrogen always terminal, then rest, the two elements, you see which one is least electronegative. Then what you do is, you join the terminal atoms to the central atoms by a single bond. Don't worry about the shape. We are not concentrating on the shape now. I'm first explaining to you how to derive the structure, not the shape. So don't worry about the shape. Any way, any shape you like, doesn't matter. You just combine the terminal atoms to the central atom by single covalent bond. This is the first rule of the Lewis theory. Identify the central atom and combine the terminal atoms to the central atom by single covalent bonds. The second rule is to establish the total number of valence electrons. Now what is meant by valence electrons is the electrons in the outermost shell. What is that? The valence shell. In other words, that's the group number. The group number corresponds to the number of electrons in the outermost shell, right? So sulfur is group 6. So sulfur has 6 electrons. Oxygen is group 6 again. It has 6 electrons. You can notice there are 3 oxygens, so 6 times 3 is 18. So overall there are 18 electrons in the valence shell. Right? Why we consider only the valence shell? Because that is a shell which takes part in bonding. That is the outermost shell, the shell which takes part in bonding, right? So we only concentrate on the electron arrangement on the outermost shell. So now here you have 24 electrons. You notice a 2- charge here. Therefore, for each negative charge, you add an electron, and for each positive charge, you subtract an electron. There's 2 minus charges, therefore I add 2 electrons here. So I got 26 electrons in the outermost shell of these 4 atoms. That's the second rule of the Lewis theory. So what is our attempt now? Our attempt here is to derive the shape. We taught memorizing shapes of each and every molecule. We have 6 rules, known as Lewis rules. If you follow those 6 rules, you can derive the structure of any complex molecule. The first rule of the Lewis structure says to identify the central atom first. What is the central atom? That's the least electronegative atom. Right? So sulfur is the least electronegative atom. And connect the rest of the terminal atoms to the central atom by single covalent bond. Don't worry about the shape. Any way you like, you can combine. Right? Remember, hydrogen will never be the central atom. Hydrogen always occupies the terminal position. Second rule, you should establish the total number of valence electrons. That's the number of electrons in the outermost shell. In other words, that is the group number. Sulfur, there are 6 electrons. The group 6, oxygen, there are 6 electrons and there are 3 oxygens. 6 times 3 is 18. 18 plus 6 is 24. Because there's 2 minus, you need to add 2 electrons to this 24. For each negative charge, you need to add an electron. If it's 3 minus, you add 3 electrons. If it's 2 plus, you subtract 2 electrons. If it's plus 1, you subtract 1 electron. This is the second rule. The third rule, if anyone is not clear with the first 2 rules, please let me know. Don't wait till the last minute till I finish 6 rules and don't say any second rule, right, to explain again, because you will not be able to understand the rest of the rule, because the next rule is based on the previous rule. So if you don't understand the first and second rule, please let me know now itself. I'll re-explain again before you move on to the next rule. The third rule is that the first rule is that, yes, I'll explain again, we have to understand which atom is a central atom. Which atom is central? The least electronegative atom. Sulfur is below oxygen, right? So that becomes a central atom. You connect the terminal atoms to the central atoms by single bonds. If there's hydrogen, that will always occupy the terminal portion. Is that clear, Seluna? Hydrogen will never be the central, so we always occupy terminal position, right? The third rule, anyone not clear with the first 2 rules, please let me know, otherwise you will not understand the whole lesson. You will not know the rule 3, 4, 5, 6 if you are not aware of the first 2 rules of the Lewis theory. Anyone needs these first 2 rules to understand? Okay, everyone is fine. Okay, the third rule, you have to deduct 2 electrons for each bond which you have drawn, because one covalent bond is 2 electrons, a dot and a cross. There are 3 covalent bonds. Therefore, in this structure, there are 6 electrons which I have already shown out of 26. So out of 26, you have already shown 6 electrons. Deduct 6 electrons, you have 20, and you convert that into pairs by dividing it by 2. So in this sulfite molecule, there are 10 pairs of electrons in the valency outermost shell. The third rule clear? For each bond, subtract 2 electrons. For each bond, subtract 2 electrons, right? And convert that into pairs by dividing it by 2. Clear? Then the fourth rule, you have to distribute these 10 pairs among the terminal atoms first. I'm going to just write numbers here, because the reason each number corresponds to that rule number. But for the first, second, third molecule, when you practice, you can put numbers and you will know which rule it corresponds to. And then once you master it, you will do everything in one molecule. Don't worry, right? You can just within 10-15 minutes, seconds, you can derive the structure in the same molecule. Now the 10 pairs I'm going to distribute first among the terminal atoms, so that all the terminal atoms receives their octet, meaning 8 electrons. I can put 3 pairs on this oxygen. Why 3 pairs? Oxygen will have 8 electrons overall. You have to 3 pairs, right? 1, 2, 3, 4, 5, 6, 7. And this electron from the sulfur, after forming the bond, it has 8 electrons. Remember, any period 2 molecule, any period 2 element can have maximum 8 electrons. 2s2, 2p6, maximum 8. If it's period 3 like sulfur, it can have maximum 18 electrons overall. 3s2, 3p6, 3d10. 2 plus 6, 8, 8 plus 10, 18. So I can put maximum 3 pairs in each oxygen. So out of 10 pairs, I can put 9 pairs on the terminal atoms on oxygen, and the remaining pair, if anything remaining, after distributing the electron pairs first among the terminal atoms, if anything remaining, that goes to the central atom. That goes to the central atom. The 10 pairs is first 9 pairs among terminal, and the remaining one goes to the central. That is the 4th rule. Right? And the 5th rule, you look at the central atom. You look at the central atom. Check whether it has got its valence electrons. The 4th rule is simple. So here what you should do is the 10 pairs you distribute first among the terminal atoms so that each atom gets its electrons. Oxygen can hold 8 electrons, so I can put 3 pairs, so 3 times 2 is 6, and this bond is 2 electrons, 6 plus 2 is 8. Right, so I can put 3 pairs on each oxygen, 3 times 3 is 12, or 3 times 3 is 9, and the balance pair goes to sulfur, 10 pairs. Is that clear? Right. The 5th rule, you look at sulfur. Check whether it has got its valence electron, not the octet, the valence electron. That means sulfur should have 6 crosses around it. 6 crosses, 6 electrons on its own. Look, this bond is a dot and a cross. This bond is a dot and a cross. And this bond is a dot and a cross. How many crosses are there around sulfur? How many electrons are there around sulfur? Only 5, right? 1, 2, 3, 4, 5. Only 5 electrons. How many electrons sulfur should have on its valency outermost shell? Sulfur should have 6. The group 6. Then 1 electron is missing. In that case, what we do is we convert this one of the lone pairs to form a double bond. Now look, now the sulfur has got the 6 electrons, 6 crosses around it. Each bond is a dot and a cross, so you have 1, 2, 3, 4, 5, 6 crosses around sulfur. Sulfur has a valence of 6 electrons. It has got the 6 valence electrons. But overall, if you add, then the molecule will have more than 8 electrons. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. Sulfur can hold 10 electrons because it's a period 3 element. It has 3 shells. Outermost shell can hold up to 18 electrons. 3s2, 3p6, 3d10. Is the rule 5 clear to everyone? That is very simple. I'll repeat again. Look at the central atom. Check whether it has got its valence electrons. Sulfur has only 5 electrons, 5 crosses around it. It needs 1 more electron. Then you convert a lone pair to form a double bond. That's all. Any oxygen's lone pair.